Okay, يا شباب. So last time يا شباب we talked about the applications of steady state control volumes, where we talked about some common devices in engineering that it usually runs at a steady state operation. And in the steady state operation, we saw that the rate of mass change within the control volume and the rate of energy change within the control volume is constant with time, or basically the rate of change is zero, which means the mass and the energy of the control volume does not change with time. And we applied the energy and mass balance for these devices يا شباب, and then took few examples. We took a couple of examples. This is in the last lecture. We looked at a couple of examples for the steady state operation control volume. Today, Shabab, we're going to look into, inshallah, the applications of the unsteady state, or what we call transient control volumes. So the word unsteady, from the name, it means not steady, or the opposite of steady, which is the state is changing with time. Okay, so when you hear the word transient operation, it should come to your mind immediately that it means this operation is unsteady, or the state or the variables of interest, or the, in this case, for example, mass and energy is changing with time. An example is what, Shabab? For example, the starting up and shutting down of devices. Okay, so when you just start up a device or you shut down a device, this is a transient operation. على سبيل المثال يا شباب, محرك السيارة, whenever you start the engine of your car, before you start the engine, there is no fuel, there is no air, there is no fluid inside the engine, the combustion chamber. So when you start your car, you start injecting fuel and air, you start your crankshaft start rotating, your cylinders start moving from zero velocity to certain velocity. Okay, so this operation from time zero to certain time t is a transient operation. Another example, if you are, for example, filling a tank or emptying a tank. Let's say the tank is empty, there is zero mass inside the tank, and you start filling the tank from time zero until certain time t, where you have certain mass of the control volume at that time t. This is also a transient operation. Okay, so this is what we're gonna focus on today, ya shabab, is we're gonna focus on the unsteady state control volumes and the application and the derivation of the mass balance and the energy balance for the unsteady state or transient control volumes. واضح يا شباب? Is it clear what we want to do?
Yes.
Any questions so far? طيب تمام. So let's start with the mass balance for the unsteady state transient or transient control volumes. For the transient control volumes يا شباب, the mass balance, the mass rate balance يا شباب, is similar, very similar, it's the same actually as the steady state. So if we go back to the steady state operation, just give me a reminder here. When we looked at the steady state operation, this is the energy, and I think before we talked about the mass balance. You see that the mass balance here is simply the same as what I wrote there. So the rate of the mass of the control volume with time equals the summation of mass flow rate inlet minus summation of mass flow rate exit. This is exactly the same here. طيب يا شباب, can I use directly this equation in the analysis? let's say I give you the mass at time 0 and I ask you, for example, for the mass at time t, at certain time later. Is this equation can describe this? ما أدري سؤالي واضح ولا؟
I think yes.
I think yes too.
So can I use this equation to describe the mass at any moment in time?
Yes.
How? What is the form of this equation? Let me give you a basic question. Basic math calculus. What is the form of this equation? انتم عارفين ال equations are عندك different types of equations. What is this equation? What does it,
Summary.
what does this d by
Wait.
dt? Huh?
Change of the mass over the change of time.
Yes, but what is the mathematical name for it? This is differential.
It represents the slope.
Huh?
It represents the slope.
اوكي كل كلامكم صح لكن ارجعوا للنيم الاصلي. This is differential صح؟
It's
This is a
differential,
derivative.
yes.
This is a derivative. So this equation is a differential equation. تمام? Let me give you quick يعني brief, maybe it's important for some of you or all of you, I don't know. لكن يا شباب why يعني in engineering and mathematics, why do we care about these differential equations? Why they are important? Okay? So بكل بساطة يا شباب احنا في الانجينيرينج يعني لما تسمعون ريسيرش ناس يسوون ابحاث ولا engineer trying to solve certain problems, احنا بكل بساطة what we are trying to do انه I have a certain phenomena, عندي ظاهرة طبيعية والله عندي مثلا fluid flow, عندي temperature change okay within from certain for example with time or whatever, the steady state operating control volume something يعني I have a phenomena and I would like to represent it as what. So the objective usually for engineers and researchers is they want to explain this phenomenon. Okay? فيكون عندهم ظاهرة طبيعية مو عارفين يشرحونها أو they want to explain it. What is the best way to explain it يا شباب? The best way to explain it is to represent it as a form of a mathematical equation, a mathematical formula. Okay? فلو عندك equation تعطيك مثلا تغير درجة الحرارة مع الوقت مثلا. Okay? In terms of the parameters relevant to the phenomena. For example, let's say you have velocity, maybe density, etc. Okay? This is shows in this equation. فالهدف يا شباب الأساسي لما تسمعون زحمة الريسيرش وما أدري وشو بكل بساطة this is what they are trying to do. They have a phenomena. They want to represent this phenomena as a mathematical form. As a mathematical form. ليش؟ وش الهدف لما يكون عندي equation؟ If I have an equation يا شباب خلاص الموضوع صار بسيط. I can control this phenomena. I can play with it. I can design an application with this phenomena so that I can know exactly what happens. I know exactly how the temperature at certain time, for example, as this example here. So that's why it's important to represent the phenomena in real life, the physical phenomena that we see in nature, as a mathematical equation or a math equation. طيب السؤال الحين how do I reach this equation؟ صح؟ هذا الحين السؤال يجي في بالكم. طيب كيف أوصل للإيكويجن هذه أصلا؟ إحنا نوصل للإيكويجن هذه نفس بالضبط ما سوينا في هذا الكورس يا شباب. إذا تتذكرون مثلا في الستيدي ستيت what did we do؟ في الانرجي بالانس، في الماس بالانس what did we do؟ We wrote we put our مثلا system, and then we put directions for the flow, for example, or the energy, and the energy in, energy out, energy changing. Okay. تذكرون في الفيزيكس سويتم الفري بودي diagram، ترسمون forces على البودي. This is يا شباب called first principle. You starting or deriving equations from first principles، بحيث انك تحط السيستم حقك، تحط الظاهرة حقتك الطبيعية، تحاول ترسمها، بعدين تشوف وش القوى، مثلا forces affecting this, what is the energy change, what is the different energy transfers, etc. So I write energy balance, mass balance. So this is how I can derive this mass balance, and this is how actually we derive this mass balance in this form of the differential equation. Okay. ف خلوني ألخص اللي قلته عشان السؤال الحين، كيف أحصل على الإيكويشن اللي تمثل لي الظاهرة الطبيعية؟ عن طريق ال first principles، deriving equations from first principles. And usually يا شباب، وهنا النقطة المهمة، most of the time when I derive an equation, I want to derive an equation from first principles, like I put energy balance, mass balance, forces, whatever, I end up with a differential equation. دائما يعني 99% you end up with a differential equation. تبدأ من ال first principles, you put your equation، يعني put your terms, then do some mathematical procedure, you end up with a final differential equation. الديفرنشال equation هذه يا شباب اللي توصل لها انت في الديريفيشن يحتاج لها حل. ليش؟ لانه اذا حليت الديفرنشال هذه خلاص تحصل على البارامتر حقك as a function of all other parameters. اوكي. لانه الديفرنشال equation زي في الحاله هذه have dm by dt. فاللي ايش اللي يتغير هنا يا شباب؟ ها قولوا لي ايش اللي يتغير هنا؟ what is the thing changing؟ the mass of the system، صح؟ فالسؤال الحين انا قاعد اعطيك السلوب حق التغير. السؤال انا ما ابغى السلوب، انا الحين ابغى ايش؟ ابغى تعطيني الماس نفسها how does it change as a function of time equals. ابغى الايكويشن هذه اللي هي mass control volume as a function of time equals what؟
I think there is a density.
مثلا يعني بيكون في مثلا density، بيكون في temperature، بيكون في mass flow rate whatever. فالسؤال الحين how do I go from here to here؟ وش وهذا الشيء تعرفونه انتم.
You integrate.
يا سلام. We usually integrate. Okay. We usually try to integrate to solve differential equations. طبعا يا شباب this is generally speaking، لكن انتم عارفين في different types of differential equation. في first order، في linear differential equation، في non-linear differential equation. It depends. Okay. In this case يا شباب our equation here is simple. Simple or a simple يعني first order differential equation that we can solve and it's linear. We can solve easily here. Okay. So ملخص الكلام يا شباب انه in the unsteady or transient operation, because the mass of the system is changing with time, I cannot work with the rate form. في الsteady state I worked with the rate form. ليش؟ لأنه this term was zero. There is no change with time. However, in this unsteady operation, I cannot work with the rate form. I need to solve or integrate this rate form in order to find an equation for what is the mass at time 0, what is the mass at time t, how much mass entered from time 0 to time t, how much mass left my system from time 0 to time t. So I need to integrate this equation in order to find a form for the mass balance in terms of the regular form. Okay. So هذا كان ملخص الكلام. حاولت أعطيكم يعني brief motivation about يعني mathematics and physics in nature يعني or phenomena. Okay, how we usually try to represent phenomena. طيب خلونا نسوي integration للmass rate balance هذه. So when I integrate from time 0 to time t, what do I get? I get this equation. I have 0 to t dm cv by dt, since this is the integration, now I'm integrating. The same thing goes for the other terms, for the summation m dot I and for the summation of m dot x. Okay, so انتم عارفين يا شباب, if I integrate a derivative like this, I have this is simple derivative dm by dt, so the integral of dm by dt is simply what? Huh? يلا
The mass of control volume at T.
exactly, the mass basically, so derivative of an integral is just they cancel each other or they remove, and you retain the original parameter here, which is the mass of the control volume. Now it's gonna be from time 0 to t, so when you take the difference, it's gonna be t minus 0, صح? So you reach this one here, m control volume at time t minus mass of the control volume at time 0. That's why I said this is a simple differential equation. It can be easily solved like this. So this is the mass at time t minus the mass at time 0 within the control volume. طيب, how can I continue solving this here? If you notice يا شباب here that this is one of the properties of summations. So summation can be go outside. So the integral of a summation is basically same as the summation of the integral. So I can take the summation out. Okay, and then I end up with this integral from time 0 to t of m dot I dt, and then this is integral from 0 to t m dot e dt. Remember يا شباب, what is m dot I? M dot I basically, if we go back to the original definition, is basically m dot, if we say I here, is m dmi by dt. So it's going to be very similar to this one here. So the integral of this one, dt, you just retain what? Retain mi here, for example. What is this? Ha, Shabab? Can I ask you what is mi in this case? What is the physical definition for it here?
The input mass.
Exactly. The amount of mass entered my system. And m dot e would be the amount, so this represents the amount of mass entering inlet I from time 0 to time t, and m dot integral of m dot e dt is basically the amount of mass leaving the exit I from 0 to t, and then we call it just mi and me. Okay, so simply it's gonna be me, which is how much mass entered the system, and me, how much mass exited the system. And this is يا شباب now my mass balance for a transient operation control volume. Okay, فلو تلاحظون انه how much mass entered my system through the inlet minus how much mass left my system through the exit is equal to the mass finally of the system minus the mass initially of the system. أي سؤال هنا يا شباب? Any question here? Any questions? طيب يا شباب. So this is the part of the mass balance and the derivation for the mass balance equation for a transient control volume. طيب خلونا نقول خلونا ننتقل الآن للenergy balance for the transient operation. For the energy balance يا شباب, it's gonna be very similar. So if we go back to the energy balance here, let's say, is it here? If we go back to the energy conservation of energy for a control volume, if you remember, we worked with this energy rate balance. Okay, we worked with this energy rate balance, and we saw that for the steady state we made this equal to 0, and we worked with the energy rate balance. In our case today, Shabab, for the transient control volume, we're gonna do a very similar to what we did to the mass balance. We're gonna take this rate form and then integrate it and finally find the equation for the energy balance using the regular form. So we can do this, and it's gonna be very simple, inshallah, like this. This is basically it here. So what we have is we're gonna integrate the energy rate balance, ignoring the effect of kinetic energy and potential energy. So this is a simplification, inshallah. So we're gonna neglect the effect of kinetic energy and potential energy, and if we do this and follow similar procedure to the mass balance, and you can try it, we get this here. The internal energy of the control volume at time t minus internal energy at time 0 equals amount of heat transferred to the control volume from time 0 to time t minus the energy transferred by work from time 0 to time t plus summation of integral of m dot I hi dt minus summation of integral m dot e he. I forgot to add dt here, and h here is basically ايش يا شباب؟ h is basically the enthalpy, if you remember. So h is the enthalpy. فلو تلاحظون هنا الفرق هنا يا شباب وشو؟ انه الانتجرال هذا عندي ال m dot I multiplied by the enthalpy, so I cannot just simply remove the integral. So this is more of a little bit more complicated here. I have the mass flow rate is multiplied by the enthalpy here. Okay, so this is the energy balance for a transient control volume. طيب بما ان الايكويشن الحين صارت a little bit complicated، يعني صار فيها integral هنا ممكن يكون صعب. Okay, احنا as engineers what do we usually do if we want to simplify for analysis? What can we do يا شباب؟
Make assumptions.
يا سلام. اوكي، نحب نخرش عشان نحل المشاكل. خلينا نكون معكم صريحين، يعني خرش يعني يصير في خرش، لكن يصير scientific، يعني في فرق. يعني when you do scientific approximation, when you do scientific, you reach maybe 80% of the solution, 90% is good enough for engineers. Okay, so in this case ترى اسحب كلمة خرش، يعني ما قاعدين نخرش هنا. ف as engineers we tend to make assumptions in order to simplify analysis. طيب what can we make assumptions here? I will present to you 3 different assumptions, and I'm gonna call it special cases. Okay, so the first assumption again is related to this integral. I'm gonna assume my hi here and he is gonna be constant with time. So I'm gonna assume that the enthalpy does not change at the inlet, does not change with time, and the enthalpy at the exit also does not change with time. فلما يكون ال hi وال he constant, they can come out of the integral, and then I'm reduced to what? To the integral of m dot I dt and integral of m dot e dt. وهذا يا شباب يسهل لي الموضوع، لأنه now similar to the mass balance, similar to what I did to the mass balance, I can simplify my formula here. Okay, and then I end up with mi hi. Mi is how much mass entered my system from time 0 to time t, and hi is the enthalpy. Okay, enthalpy which is constant throughout the time. Is the enthalpy at the inlet. Me here is how much mass left the system from 0 to t, and he here is what is the enthalpy. This is the enthalpy at the exit state. Okay, فبالتالي احنا بسطنا الموضوع. We made an assumption here and we simplified our problem, and then I end up with here summation of MIHI minus summation of MEHE. اوكي، فصار الموضوع الحين اسهل. اوكي، صار الموضوع اسهل لنا. اي سؤال هنا؟ وضحت فكرة ال constant enthalpy and why is it important to assume this here?
Yes.
طيب الاسامبشن الثاني يا شباب، لو تلاحظون مثلا زي ال internal energy، إذا تتذكرون during my steady state or even for a closed system I wrote my U as mu. Okay. For transient operation يا شباب, when we look at transient operation خلينا نقول عندي pipe في flow and this is changing with time. I have inlet here I have exit for example E and I have control volume here. لو تلاحظون يا شباب انه this equation might not be accurate or خلينا نقول this equation might not be applicable for this transient operation. ليش؟ لأنه this U is changing with time, so U is a function of time, and also is not function only of time, is also function of the space, the position. We call it, let's say call it X. فلو عندي البايب خلينا نرسمه كذا، هذا الانلت مثلا بايب، فممكن اليو هنا is different from U here, is different, let's call it 1, 2, different from U 3. فبالتالي when I want to write U equal mu for a transient operation, this might not be accurate, this might not be true, because my U here is different with position and with time. Okay, فبالتالي يا شباب this can complicate my analysis here. Okay, this can complicate my analysis. What can I do? What assumption can I make? Hi Shabab. Any guess? Anyone?
Fix the position of the internal energy of the U. For
Yeah,
example, the
salam.
center.
Yeah, salam. So we can assume that the intensive properties of my system is uniform with position at any time t. يعني لو أخذنا t1 مثلا or t equal 10 seconds, I'm gonna assume that my intensive properties everywhere in position or space is uniform. فبالتالي this makes my analysis much simpler by assuming the intensive properties within the control volume are uniform with position at time t. فبالتالي I can now use these basic equations. I can use the specific, I can write the mass of the control volume as volume and specific volume, and write the internal energy as mass times specific internal energy, and so on. بس لو تلاحظون this is only with position. This is uniform only with position. However, you can see here I'm writing it as a function of time, function of time, function of time. So at any time t, I can write this equation because they will change with time. That's the idea. The mass will change with time. The properties will change with time. But I'm gonna assume that at any time the properties are uniform with position. This is the second assumption here. Any question about this assumption? Any question about this assumption here? طيب, the last assumption here يا شباب, or a special case I would say, is in many of the problems يا شباب we encounter in transit operation is this case. So if we have a container and we try to fill a container with one inlet and no exit, okay? يعني مثلا عندك كاسة مثلا قاعد تعبيها موية. So this is a container with one inlet and no exit. So whatever mass you are filling, it stays. So nothing goes out. Okay? And if you have this case, I can simplify my analysis, okay, and using mass balance as well. So I can rewrite my energy balance as U at time t minus U at time 0 equals Q minus W plus MIHI. ليش MIHI؟ لأنه ما في summation, I have only one inlet and I don't have any exit. Okay, so that's why I have MIHI. طيب, I can remove this MI and put this mass balance. So if we go to the mass balance, I have M of the control volume at time t minus mass of the control volume at time 0 equal Mi minus Me. And since I don't have any mass exiting, leaving my system, then I'm left with Mi equals basically Mt minus M0. And this is exactly what I wrote here. So I remove Mi and put Mt minus M0 and the whole thing multiplied by the enthalpy at end. Okay? And here I also wrote U using the assumptions before as M times U at time t minus M times U at time 0. Okay, so this is the last special case that we can look at here. أي سؤال يا شباب؟ أي سؤال؟ That's it يا شباب. So this is all, this is the whole story in this case. Similar to the steady state operation, since I have mass balance and energy balance, this is exactly the same. I have mass balance and energy balance. The main difference between steady state and transient operation is that for the steady state I work with the rate form. For the transient operation I work with the regular form, and as you can see. أي سؤال? Any questions here? Questions? طيب, so we have time to take, I guess, one example for this transient operation case. Let us see here. Okay. So let us look at this example. So I have a tank. I have a tank like this. إن شاء الله ما أجيب بعيد في الرسم. I have a tank something like this. Okay. So this tank contains saturated mixture. And saturated mixture, so I have liquid here, saturated liquid, and it's saturated base. So this is water. So the volume of the tank is 0.85 meter cube. Okay, this is the volume of the tank. So the initial state is, as I said, the saturated liquid mixture, and the temperature and pressure or quality. So the temperature here, T1 equals 260 degrees Celsius, and x1 is 0.7. x1 is equal to 0.7, which means 70% of this mixture is saturated vapor. الحين وش اللي قاعد يصير؟ What we did now, there is a valve here attached to this tank, okay? So there is a flow valve here. And what I try to do now, I slowly try to take out the saturated vapor, okay? So basically, the state here, so I'm slowly withdrawing the saturated water vapor at 260 degrees. So this is saturated vapor is removed. Somewhere else. Saturated water vapor is removed while heating the tank. ليش يا شباب I'm heating the tank? So I'm basically heating the tank while removing this saturated vapor. Why? Because I want to keep the pressure inside the same. Okay? I want to keep the pressure inside constant. So that's why I'm heating the tank. What is the final state يا شباب? So the final state of this tank is all the liquid transforms into saturated vapor. Okay? So I withdraw saturated vapor and I heated the tank until the whole tank now. So this is saturated vapor and this is saturated liquid. Now this is completely saturated vapor. This is initial. This is final. Okay. وضحت البروبلم يا شباب؟ عندي تانك في saturated mixture، بديت أسحب saturated vapor through a valve slowly while heating the tank at the same time in order to maintain the pressure constant, and I'm basically making the pressure constant until all the saturated liquid transforms into saturated vapor. So the question is, how much amount of heat transfer was needed to transfer, or how much, what is the amount of heat transfer, basically, that's the question. So find Q neglecting kinetic energy and potential energy. اوكي يا شباب، هذا السؤال. شباب واضح السؤال؟ Is it clear؟
واضح.
طيب، فلما نجي نطالع البروبلم هذه، and this is يا شباب for your information, also for the final exam إن شاء الله later, you might have a problem which is transient, a problem which is steady state. How do you know if it is transient or steady state? You need to go back to the concept. So since there is mass, so since there is mass crossing the boundary, you know this is a control volume. This is the first point. the second point. Since the mass is changing within the control volume here, ya shabab, since the mass is changing within the control volume, then you know this is a transient case. If the mass is not changing or the problem tells you it's steady state operation, then you know it is a steady state operation. Okay? So, how can we solve this? Now, when we look at this, this is, so let's write it here. This is a transient control volume with one, ها شباب, one exit ولا one inlet?
One exit.
One exit and no inlet. Okay? And no inlet. So if we go back to our equation that we derived before for one inlet and one exit, it's gonna be similar, but instead of MIHI, it's gonna be what? It's gonna be minus MEHE. Okay? So basically, let's derive it here. Let's derive first. الحين again السؤال يبغى الهيت transfer. Okay? Since this is a transient control volume with one exit and no inlet, to find the heat transfer خلاص أعرف على طول إنه لأن هذه transient control volume, I will apply the transient control volume energy balance. Okay? So I will apply this equation energy balance, which is the first one here. Let's write it. So I have U control volume at time t minus U control volume at time 0. Remember this, neglecting kinetic and potential. It's going to be Q minus W, so plus MIHI minus MEHE. So I have one exit and no inlet, so this is going to be 0. Is there any work done, ya shabab? Is there any work done?
The volume is constant. The pressure is constant. So I think no.
Not only this, the work, remember, the work is not only related to the, you should know by now that the work is not only related to volume change. Okay? So you can see there is no mechanical effect, there is no electrical effect, there is no rotating shaft, for example, there is no boundary work or expansion or compression. Because of this, I can say, I can assume, or I can put work equal to 0. Okay? So this is exactly the same concept as the work that we have learned before for a closed system. Okay? So the final equation describes now, so basically Q is going to be equal to, I'm going to write this as M at time t. Let me call it 2, which is at state. The final state, ya shabab, I will call it 2. And the initial state, I will call it 1. So M2U2 minus M1U1, which is the initial state, is going to be plus, so this plus M exit H exit. طيب وش الام exit يا شباب؟ الماس بالانس وش تعطينا؟ The mass balance, I have M2 minus M1 equals to Mi minus Me. And since I don't have any mass inlet entering the system, I end up with Me equals to M1 minus M2, which is the initial minus 5. Okay, so let me put this here. So the Q equals M2U2 minus M1U1 plus I have M1 minus M2 times HA. That's it, ya shabab. So, since this is saturated mixture and I am withdrawing saturated vapor, خلاص, this is saturated vapor state. at this temperature and saturated pressure. Okay, so I can find the enthalpy at this state for HE here. Okay, so I can find HE. What about M1 and M2? Okay, what about M1 and M2? Can I find it or not? Again, M1, U1 and U2, you find it at initially, U1 initially basically will be what? For the saturated mixture. U2 will be for the saturated vapor. Very similar to what we did in evaluating properties. Okay? And the masses, how can you find M1 and M2? شباب? How can you find M1 and M2? ايش تتوقعون؟ يلا شباب ابو واحد سريع كذا يعطينا الفكرة، الوقت خلص.
I already have volume, I have quality, I can find specific volume and evaluate the mass.
بس that's it. عندك الفوليوم for the tank. Initially and finally the same volume. فبالتالي إذا أوجدت the specific volume at 1 and the specific volume at 2, you can just simply find the mass M1 and M2. خلاص تصير عندك M1 M2 وعندك U1 U2 وعندك HE. You can find the heat transfer. It's very straightforward, very simple. Just applying the same concepts that you have learned. Okay, so time is up يا شباب. I will finish up this equation and this solution and then you can look at it at the lecture notes. But you should be able now inshallah. يعني I explained to you the important thing. أي سؤال يا شباب؟ أي سؤال before using this?
Yes, for this specific problem, we're just considering the mass in the tank or in the system. We're not interested in the mass exiting the system.
بس شوف لو تلاحظ الماس exiting the system هي عبارة عن ايش؟
Yes.
It's a function of the mass of the system itself. فبالتالي usually this is what I do for the energy balance and the mass balance. I use the mass balance and احطوها قاعدة. راح استخدم الماس بالانس في الانرجي بالانس. ليش؟ عشان اشيل الماس exiting الام اي ولا الام اي واحط بدالها الماس اوف ذا سيستم، بتصير الايكويشن حقتي كامله فيها بس properties of the system only without inlet and exit. يعني الافكت حق الماس inletting ولا الماس exiting is already as a function of the system mass. وضحت؟
Yes, thank you.
Good question. فمو انه I'm not interested, it is already included. يعني the effect of inlet mass entering and mass exiting already included. Of course I am interested in that. Any other question? اوكي يا شباب موفقين باذن الله. بالتوفيق. I'll see you ان شاء الله. الله يعافيك. ترى يا شباب يعني we're like this with this chapter. I will see لأنه we are a little bit behind. I might start the next chapter next class يعني next week إن شاء الله. Okay. And I will try to give you also maybe على فكرة الhomework already posted for I think steady state. So just take a look at that. Okay. Good luck.